Welcome to EDU World Space.
To determine whether or not a molecule is chiral, we need to first produce its mirror image, and then from its mirror image determine whether or not that mirror image is superimposable upon the original. That then is the definition of something that is chiral. Molecules for which their mirror image is not superimposable upon the original molecule. The first molecule that we have is this one here. If we now draw its mirror image, we'll have two blues on the far end. We'll have two blues here mirroring these ones, and then we'll have a green down and this green mirroring this green. Now if we were to take this and rotate it 180 degrees, this would end up right here, and it would be going up to, well, let's see, this would end up right here, and it would come over to this one, which is going to end up right here. So both of those match. Rotate it 180 degrees in order to put these two right here. This green one ends up right here. So although when we rotate it 180 degrees, we can get these two to superimpose, this green one is going to be right here, which would be right here. So the green one is out of place. It needs to be right there. So these two are non-superimposable, and this original molecule is chiral. The next one is this molecule here. Let's draw its mirror image. So we've got this green matching this one, these two blues matching these two, and then we've got this green one matching this one, and these two matching these two. Now if we were to rotate this 180 degrees, actually, not even 180 degrees, if we were to just rotate it 90 degrees this way, so that we put this blue one in this position, then this blue one would be right here, still connected to the top. This green one would go right there. We have a green one there. This green one would go right here. We have a green one there. And then this blue one would go right here. We have a blue one right there connected to the blue on the bottom. So rotating that 90 degrees, it is now superimposable upon the original. So this one is not chiral. And for the next one, let's draw its mirror image. Got blues everywhere. So these two mirror these two mirror these two, and then these two mirror these two. Okay, so we need to get both of these over here. So if we rotate it 180 degrees, these two will be right there. This one will be over here. So we will have this blue one over here connected to the bottom. So we'll have a blue one over here connecting to the bottom, not to the top. So rotating this 180 degrees, in order to get this over to here, we now have something that is not the same, so it's not superimposable upon the original, so this one would be chiral. And if we were to, let's go back to this one, if we rotate it 180, then this one ends up in this position, and it is going down instead of up. So if we flip it 180 degrees to get this that's going down to go up, then it's going to flip from this position to this position, and when we do that, it's now going to be going up it's still not going to be the same. So no matter how you try it, this cannot be superimposed on this one. So that one's chiral. For the last one, we have something like this. So if we take this and we rotate it 180 degrees in order to get these two greens in this position right here, when we do that, this blue is going to be 180 degrees. It'll be right here, and this blue does not connect to the bottom. It's this blue that's going to be now up here connecting to the bottom. So this cannot be superimposed on this. So it is also chiral. So to review, 1, 3, and 4 were all chiral species because their mirror images were not superimposable upon the original molecules.